In this video, we're going to take an derivative using substitution. And before we do that, let's go over a simple derivative. So you have quantity x cubed minus sine x. So if you want to take the integral or derivative of this, it will be x to the fourth, x to the 4 over 4. And then what's the derivative of negative sine x? That will be positive cosine x, and then plus some constant. And you could double check by taking the derivative of this whole thing and see if you get x cubed minus sine x. What about this problem right here? In order to take the antiderivative, you want to rewrite this as 12x to the negative fifth plus x to the negative 1/2. Now remember, whenever you want to take the antiderivative of x to the n dx, where n is an irrational number, the antiderivative becomes x to the n plus 1 over n plus 1, and then plus c. So for example, here the n was 3. So n plus 1 becomes 4, and then whatever you get, you have to divide by that. So here, what's going to happen is you're going to get x to the negative 5 plus 1, which is negative 4. You already had 12, and then you have to divide by negative 4. Plus x to the, you had 1, you're going to get 1/2. Divided by 1/2 plus c. And you need to clean it up using algebra skills. You get negative 3 x to the negative 4 plus 2 x to the 1/2 plus c. Of course, you could rewrite this as negative 3 over x to the 4th plus 2 radical x plus c. And these two are the same thing. Let's take a look at this example. You got sine of quantity 3x plus 2 inside the integral. So here we're going to use what we call a u sub. We're going to let u equal to 3x plus 2. And what is the derivative of u respect to x, which is du over dx? That's going to be 3. Now notice, what is dx? Now we have to change everything in terms of u. So dx, if you cross multiply, you're going to get dx is du over 3. Okay, you just cross multiply and solve for dx. So you could rewrite this as integral of sine quantity 3x plus 2 becomes u. And what is your dx in terms of u? That's du over 3. Now, 1 over 3, we could take it out. It's a constant. Now, what is the antiderivative of the sine of u? That's negative cosine of u plus c, and then you had a 1/3 in front of it. So now, what was our u? That was quantity 3x plus 2. So this is the integral or antiderivative of this problem. Okay, let's look at another example here. So notice, this is difficult because we cannot distribute x, since this is radical. So what we need to do is now we have to say u equal to x squared plus 1. Now what is du over dx? It's 2x. Okay, notice we have x dx. So if you move dx to the other side, you have 2x dx equals du. But we only need x dx. So divide both sides by 2. So you get x dx is du over 2. What about radical x squared plus 1? That becomes radical u. So you end up getting radical u, and x dx is du over 2. Notice we're just substituting in terms of u. You could take out the 1 over 2, and radical u, you could write it as u to the 1/2. Now you take the integral, or antiderivative. You get 1 over 2, you get 3 over 2, over 3 over 2, which will be 2 over 3 when you simplify. And then you have constant plus c. So multiply this out, you're going to get 1/3 u to the 3 over 2 plus c. And u is quantity x squared plus 1, so you're going to get 1/3 quantity x squared plus 1 to the 3 over 2 power plus c, and that is your final answer. Let's take a look at this example here. You got e to the radical x over radical x dx. So it's not that simple to find the antiderivative. If we let u equal, remember, e to the u du, integral of that is e to the u plus c. So if we let u equals radical x, or which is the same thing as x to the 1/2, what is du over dx? It's going to be 1/2 x to the negative 1 over 2, which is going to be 1 over 2 radical x. Now notice, when you move dx to the other side, you get dx over 2 radical x. Notice, we only need dx over radical x. So moving the 2 to the other side, you get 2 du is dx over radical x. Now using substitution, you're going to get integral of e to the u. And what is dx over radical x? That's 2 du. So 2 comes out, it's a constant. So it's going to be eu du. And what's the integral of that? It's going to be 2 e to the u plus c. And what was our u? Radical x. So it's 2 e to the radical x plus c. Now when you have an antiderivative of du over u, this will be natural log of absolute value of u plus c. So here notice, you have a polynomial as a numerator and polynomial as a denominator. But degree is higher in the denominator. So let's say u equal to 4x cubed minus 1. And what is your du over dx? It's 12x squared. So notice you have 5x squared dx. Du is 12x squared dx. Let's just divide that by 12. So that means dx squared dx is same thing as du over 12. So what we get is you have 5 already. You have 5 times x squared dx is du over 12 over u. And let's clean this up. You get 5 over 12, so I'm going to take that out. And you get du over u. So what is that part? Well, that's the same thing as this right here. So you're going to get 5 over 12 natural log of absolute value of quantity 4x cubed minus 1 plus c. Okay, what if you have this problem right here? Well, let's say what happens when you let u equal to e to the x plus 4. I know it's very difficult to know how do you know what u should be, but you'll get better at it as you do more practice. What is du over dx? E to the x. So du becomes e to the x dx. So notice, this part right here, e to the x dx, is du. So you could rewrite this as du over u, which is natural log of absolute value of u plus c, but what was our u? E to the x plus 4 plus c. Now, you don't really need absolute value here because why? E to the x is always positive no matter what x is. So you could rewrite this as using parentheses in this case. How do you find the antiderivative of tangent x dx? This is not that simple. We know that derivative of tangent x is secant square x, but what about the integral? In order to do this, you want to rewrite this as sine x over cosine x. Let u equal to cosine x. What is du over dx? It's negative sine x. So our du becomes negative sine x dx. And let's move the negative to the other side. So sine x dx becomes negative du. Now using substitution, we'll get negative du over cosine x, which is our u. So you end up getting negative of integral of du over u, which will be negative natural log of absolute value of u plus c. And what was our u? It was cosine x. And that's your final answer.